Okay, my dear friends, the picture behind me on this glass marker board is to find the volume when that picture or that region entrapped between those given two straight line. One is the above one in the first quadrant is like y equals 12 minus 4x. The other one in the below is y equals 8x minus 12, and y-axis when it's rotated about the y-axis. In order to get this done, I'm gonna read the question for you. Rotation of the region in figure below about the y-axis produces a solid with the two types of different cross sections. Compute the volume as a sum of two integrals, one for minus 12 to y minus 12, one is for when y is between minus 12 and 4, and the other one is when the y is between 4 and 12. That's exactly that description being that put it into the pictorial format behind me. And I have drawn that y equals 12 minus 4x, which has a negative slope, negative 4 is the slope, and then positive 12 as the y-intercept. Similar fashion that y equals negative 8x, y equals 8x minus 12, for that straight line, that slope should be positive 8 and the negative 12 would be the y-intercepts. These two regions are, when combined together, area entrapped between these two rotated about the y-axis, how to find the volume. In order to get this done, what I did, between 4 to 12 of y and then between minus 12 to 4 of y, I have taken two or selected two horizontal disk, or I pick some kind of a line with the thickness of dy and then sweep across the space when about the y-axis. So once you do that one, pretty much what we're gonna get it is that the one on the right hand side, two disk, one for the above part, which means like when y is between minus 12 to 4, and the other one in the below, the disk below is the one that for the when y is between 4 and 12. So let's see that how to, let's do this one part by part. Now you can see clear cut the picture, and when they both straight lines meet at y equals 4 and x equals 1/2, so its point of intersection would be plus half comma 4. Okay, so let's try to answer this question now. Since we know that the structure of this one, since we have already developed these two, let's try to answer this. In order to answer this one, I'm gonna get two different regions. First one, 4, and y is between 4 and 12. Consider an infinitesimal horizontal strip of width dy and a length x at a distance what, y plus 4 from the y plus 4 from the x-axis. So this strip has been taken, strip of, see, the strip of with dy and length x at a y plus 4 at a distance, of y plus 4 from the x-axis. So that one, the way that it is, I'm going to draw here one more time. I'm talking about this one. See, this guy, dy, this length taken from x-axis, this height would be y plus 4. This is what I'm talking about. Pretty much when this is rotated about the y-axis, it will generate a disk with dy and a radius r, which is f minus y. Okay. So let's see that when this is rotated, okay, I'm going to write here clearly, when this strip is rotated about the y-axis, a disk of width dy and a radius let's say r of x, which is the inverse of y, will be swept out. This is what we meant. See? Now we have something like this. See? It's a disk with the width dy and a radius x. See? This x, oh my god, this x, or we call this an r, radius, which is denoted by r is my x. That's the inverse function of y, which is coming from this one. You see, we can remember that is coming from y equals 12 minus 4x. We can easily get x from here. 4x equals y minus 12, therefore x equals y minus 12 whole thing divided by 4. See? That's the x. So x is in terms of y minus 12. Very easy. Now you can easily write the volume. But before that, let's write a cross section. Cross section of the disk, which is dA given by pi r square. dA equals pi r squared means y minus 12 over 4 squared. Plus pi over 16 y squared minus 12 24y plus 144. And then let's go to the volume of the disk, which is given by cross-sectional area times the width. And this is given by dV, this is by dA, this is by dy. dV equals dA means pi over 16 y squared minus 24y plus 140 times dy. If you want, you can say this one dA 1, 1, 1, 1, 1, 1. But we are taking into account that the region between y greater than 4 and less than 12. So now we can get the total volume. Total volume on, therefore total volume on the interval y 4 to 12, we can say d1. d1 equals integration dv1. dv1, when you integrate, you have a pi over 16. Here 12 squared. Actually, you don't have to do like that. I'm going to get back to the 12 minus y squared. It's easy if you keep like this. Integrate 4 to 12 dy, and v1 equals pi over 16 12 minus y whole thing cube divided by cube and negative 4 to 12. So then, when you plug in the upper bound and lower bound, v1 pi over negative pi over 48, we have a 12 minus 12 whole to the third minus 12 minus 4 to the third. This whole thing is 0. And negative, positive pi over 48 1. This one means 8 to the third. Pi over 48, 8 times 32 means 152. 1. And 4 times 16 times 3, 512 means 16 times 3, 48, and 32. And the answer is V1 equals 32 over 3. That's the first part. Okay, we're going to meet you guys in the second part, in the second video.